Today we'll do decoder. Decoder is an inverse of encoder. It performs the opposite action of encoder. It's a logic circuit which converts a binary number into other base, into a number in any other base. Okay. For example, from binary to decimal, binary to hexadecimal, binary to octal. Okay. In a decoder, if there are 3 input lines, it will be capable of producing 8 distinct outputs. Okay, if the 3 input lines are there, 8 output lines will be there. Okay, one for each of the states which the 3 inputs can take. So, if the input lines are 2, suppose the input lines are 2, then there will be 2 to the power n, means 2 to the power 2 equals to 4 output lines. Whatever the input lines, the output lines will be 2 to the power number of input lines, 2 to the power n. If there are 3 input lines, 2 to the power 3, 8 output lines will be there. If there are 4 input lines, there will be 2 to the power 4, 16 output lines. Now we'll discuss 2 to 4 decoder. 2 to 4 means 2 input lines. So how many output lines will be there? 2 to the power n. What is the value of n in this case? 2. As we are saying 2 input lines. Okay. So 2 to the power 2 means 4 output lines will be there in case of 2 input lines. Okay. Now come to the block diagram of 2 to 4 decoder. Just draw a box, a block, 2 input lines, show 2 input lines and 4 output lines. 4 output lines, 2 input lines, 2 to 4 decoder. Fine. Now come to truth table of 2 to 4 decoder. 2 input lines. So there will be column of input lines. For 2 bits there will be total 4 combinations. Okay. 0, 0, 0, 1, 1, 0, 1, 1. And 4 output lines. Okay. Output line columns will be there. Q0, Q1, Q2, Q3. 4 output lines. Okay. Now this is 0, 0, 0, 0 is binary equivalent of which decimal number? What will be the binary decimal equivalent of this combination 0, 0, 0? In decimal, this will be equivalent to 0. So, in the column of this output line Q0, there will be high value. We'll get 1 over here, as this is the binary equivalent of 0. Okay, 0. So, in this column, we'll be getting 1 and rest of the values will be 0. Okay. Now, the next is 0, 1. This is the binary equivalent of which decimal number? 1. Okay. So, Q0, Q2, Q3 will be 0. And in Q1, as this is the binary equivalent of decimal number 1. So, in this column, Q1, there will be 1. And in the rest columns, there will be 0. Now come to 1, 0. This is binary equivalent of 2. Okay, the decimal equivalent of this binary word will be 2. So, in Q2 column, there will be 1 and in the rest of columns, there will be the value for rest of the output lines will be 0, low. Now, 1, 1. This is the binary equivalent of 3. Okay. What will be the decimal equivalent of this binary? 1, 1, 3. So, in this column, there will be 1 and in the rest of the columns, there will be 0. Okay. So, this is the truth table of 2 to 4 decoder. Similarly, you can draw the truth table for 3 into 8 decoder, 4 into 16 decoder also. Okay. Now come to the logic diagram. These output lines will be represented by Q0, Q1, Q2, Q3. Okay. Two input lines, S, or you can say A, or you can take S0 or B also. Okay. So there will be two lines. How to make? This is the table. Okay. And how to make the diagram? For two input lines, you will be making one line, S or A, you can say S1, and S0, second input line. One will be complemented and one will be uncomplemented. This is the negation line. Okay. This one, S1, there will be two lines. One is for showing 1 or high value, or you can say uncomplemented line, and this one is for complemented. Similarly, from S0 there will be two lines, putting NOT gate here for complemented. Okay, one uncomplemented line from both and one complemented line. Okay, now Q0, Q1, Q2 and Q3. Four output lines, 4 AND gates are there. Okay, you will perform. Now from the truth table, 0, 0, in Q0 we are getting 1. Okay, so which one is Q0? This is Q0. Okay, this one is getting two complemented lines, from one from S1 and one from S0 in Q0. So this is complemented S1, one line from here and one line from here. And Q1, where we are getting 1, Q1, we are getting 1 when S1 is 0 and S0 is 1. For 0, 1. So S1 is 0 means uncomplemented line, and S0 is 1. 1 is decimal equivalent of 0, 1. So 0, 1. This line means 1 and this one is 0 actually. This is 1 and this one is 0. Now the next is 1, 0. For Q2 we are getting 1 where the combination is 1, 0. Okay. So this is 1 of S1, 1 and 0. Now Q3 we are getting, in Q3 we are getting 1 when combination is 1, 1. Binary is, the input lines are 1, 1. So the input lines are 1, uncomplemented 1 from S1 and 1 from S0. Okay. So this is the logic diagram of 2 to 4 decoder. Two input lines and two input lines. One is uncomplemented and one is complemented. From each input line there are two lines. Okay, one is representing 1 and one is representing 0 because of this NOT gate. Similarly here, then output lines, how many output lines will be there? If two input lines are there, 4 output lines will be there. Q0, Q1, Q2, Q3. Okay, in this table you can see we are getting 1 in Q0. Okay, this will be 1 when the S1 is 0 and S0 is 0. Okay, so this one is 0 line. So draw the or connect the input lines with the gate. Next is 0 1. So this is 0 and this is 1, 0 1. Then you are getting Q1. Okay, similarly 1 0 1 1. So this is how to make the block diagram of logic diagram of 2 to 4 decoder, and truth table and block diagram also. Okay, now come to binary to octal decoder. In octal number system, how many digits are there, numbers are there? 0 to 7 means total 8. Okay, so if 3 input lines are there, there will be 8 output lines. If 3 input lines, 2 to the power n, value of n in this case is 3, so you will be getting 8 output lines. Fine. Now block diagram you can make easily. There will be a block 3 to 8 decoder, 3 input lines and 3 4 5 6 7 8 output lines. Okay, write down 3 input lines, 8 output lines, 3 to 8 decoder. Now come to truth table first. The binary, as we are going to make the decoder 3 to 8 decoder, 3 input lines will be there, 3 bits. So this is the combination of 3 binary bits. Okay, 0 0 0 0 0 1 0 1 0 0 1 1 1 0 0 1 0 1 1 1 0 1 1 1. And this is, I have written directly, this is the binary equivalent of 0 1 1 0 2 1 1 3 and 1 0 0 4. Binary equivalent of 5 will be 1 0 1, of 6 will be 1 1 0, of 7 will be 1 1 1. Okay, now come to the diagram. We'll make this. As 3 input lines are there, A, B, C I have taken, and 8 output lines total from 0 to 7. So 8 gates, AND gates. 0, 1, 2, 3, 4, 5, 6, 7. This will produce 0, 1, 2, 3, 4, 5, 6 or 7. Okay. Then from each of the input line, there are actually 2 lines. One is uncomplemented and one is complemented one. Okay. This is showing 1 and this one is showing 0. This one is for 1. If the value of B is 1, then you will be connecting this gate to this line, and if the value of B is 0 in table, then you will be connected this gate with this line. This is 1, this one is 0. 0 because of we have connected with NOT gate. Okay. So now make the diagram. For 0, the binary equivalent will be 000. Okay. So connect this with 0. 0. Then this complemented and then this. In case of 1, 0 0 1. This will be 0. Again 0 and this will be 1. Then 2 1 0 0 1 0. So 0 1 again 0. Okay. Then 3 0 1 1. This will be 0 1 1. For 4 1 0 0. 1 0 0. For 5, 1 0 1. So 1 0 1. For 6, binary equivalent will be 1 1 0. 1 1 0. For 7, 111. All the input signals will be 1 when 1 1. Okay. So this will be the binary to octal encoder diagram. This is the logic diagram of binary to octal encoder, or you can say 3 to 8 decoder, sorry. Okay. 3 to 8 decoder, binary to octal decoder. If A is 1, B is 1 and C is 1, all are 1, then only this gate, if all the input lines are 1 high, then only this gate 7 will activate to produce a high output. The rest will be low. Only this will be producing high output because only this gate receives all the high input signals. Okay, one or more input signals to other AND gates will remain 0 for the other AND gates. Okay, one or more signals are 0. Only this one is getting all the high signals. So this will produce high output value. This gate will produce high output value for the combination 1 1 1. Okay, and that is the binary. This 7, number 7 is binary equivalent of 111. So this will, if all the input lines are high, then this gate will produce 7 high output for this number 7, and the equivalent to this binary combination 1 1 1 is 7. So this gate will produce high output.